right, guys, are there any questions over any of the assignments thus far? Questions over any of the assignments so far? Yeah, those are old. Just if you look at the date on it. In a little bit. All right, guys. Are there any questions over anything we've done thus far? Now, again, I use, especially for a lot of the worksheets that I make or note sheets, I will use the back sheets of scrap paper or old paper. And for some reason, I printed these two-sided to two-sided instead of one-sided to two-sided, so the back sheets aren't even important. But to save on paper, decided not to just trash these and then redo them. So now, what we're looking at today, the first thing we're looking at today is complex conjugates. The complex conjugate, if a function has real coefficients, and a plus bi is a solution, a minus bi. Or really what we're saying is that a plus bi, complex conjugate, is a minus bi. The complex conjugate of a plus bi is a minus bi. And the complex conjugate of a minus bi is a plus bi. Yes. Yes. But if we look at this here, so 7 minus I, what would the complex conjugate be? 7.
So why would it be 7 plus I?
Because a minus bi is 1, so its complex conjugate is a plus bi in front of I. Now there is something special with these two here, with complex conjugates. So if we'll look at 7 minus I and 7 plus I, what I want to do is multiply them together. I want to multiply these two together. Now if we multiply them together, 7 times 7 is, 7 times I is going to be plus 7I. Negative I times 7 is negative 7I. And negative I times I is negative I squared. Well, what is 7I minus 7I? 0. They cancel each other out. Well, negative I, or I squared, is negative 1. And 49 minus negative 1 is? When we multiply them together, find their product. And if it asks for their product, it would be 50. Now, the reason that this is interesting is because when I multiplied those two together, they started out with both having complex terms. I had I terms in them, yes? Their product does not. And it's going to work out if we ever get a solution that has I in it, its complex conjugate's also going to be a solution. Put it right there. Because if we have one, we have to have the other. And again, whenever we have these terms come in as a solution, it's going to be like the graphs where we grafted and didn't cross the x-axis. The solutions for these are going to have complex numbers, have imaginary terms. And most of those equations didn't have I in them to begin with. So we have to have both. If we have a negative I, we're also going to have the positive version too. Questions on any of this here? And I mean, with negative 5 minus 5i, negative 5 plus 5i, because we could type it into the calculator, negative 5 plus 5i times negative 5 minus 5i. Hit enter, and coincidentally enough, we get 50 again. So their product is 50. And that's what's kind of nice with these here, is that when we multiply the conjugates together, the I terms will cancel out, and we would just have a real number. Questions on any of this here? We ready for the next part? So what would the complex conjugate of negative 2 plus 4i be? How about 3 minus 6i? And we could multiply them together, but at this point, not too worried about that because I feel like y'all can multiply them together or at least plug them in the calculator. The complex conjugate of 10 minus 2i is 10 plus 2i. And how about negative 4 minus 8i? Questions on these here? So negative 4 minus 3i would be negative 4 plus 3i, and 8 minus 3i would be I'm going to throw another one up here. Let's see here. What would the complex conjugate of negative 9i be? 9i. All right. Ready for a tricky one? Complex conjugate of 4. There is no I. So we could say that this is 4 plus 0i, which would be 4 minus 0i. But in either case, it's just 4. Questions on this here? Now, we want to write this quotient in standard form. There's two things that we need for it to be in standard form. One is that we need to write it in the form of a plus bi, and we can't have I in the bottom of the fraction. So what we're going to do is take this here and multiply the top and bottom by the complex conjugate of the denominator. Because what's the complex conjugate of the denominator, the bottom of this fraction? Because it's 1 minus 2i, so it would be what? Because if we do 1 minus 2i times 1 plus 2i, as we saw already, that's just going to give us a real number. We're not going to have I in that term anymore when we multiply those two together. We're also going to multiply the numerator by 1 plus 2i. Now, what is 1 plus 2i divided by 1 plus 2i? 1. So am I changing the value of this fraction? No, we're just multiplying it by 1. It's a fancy version of 1, but we're not changing its value. We're changing how it looks, but we're not actually changing the fraction itself. Now, when we multiply these together, so on the bottom we'll have 1 times 1, which is 1. 1 times 2i is going to be plus 2i. Then we'll have negative 2i times 1, which is negative 2i. And negative 2i times 2i is going to be negative 4i squared. Well, in the denominator, our 2i and 2i will give us 1 minus 4 times negative 1, because I squared is negative 1. That's one of the ones that's going to be good to know because it will show up most often. As we've seen with multiplication, I squared shows up a lot. So knowing that it is negative 1 and converting it over is somewhat helpful. Well, at this point, we might as well finish this out. what is 1? Well, negative 4 times 1 is going to be what? Is it to make that plus 4? And 1 plus 4 is 5. Now we need to do the same thing with the numerator. 4 times 1 is 4. 4 times 2i is going to be plus 8i. Then we can do 3i times 1 is going to be plus 3i. And 3i times 2i is going to be plus 6i squared. I times I is, yes. Now we know I squared is what? Negative 1, yes? So really we're saying that this is being multiplied by negative 1. If we want to, we can write over the top of it negative 1. Go on and try. Yeah, go on and try it. 8i plus 3i is 11i. 4 minus 6 is 2 plus 11i. Now, to technically get it in standard form, they want us to break the fraction apart into 2 fractions. And the denominator will be the same for both. So we'd have 5 and 5. The numerators would be 2 and 11. And we get this here. Any questions on how we got this here? Okay. 4 plus 3i over 1 minus 2i. So we can try this in the calculator. So alpha y equals enter. So 4 plus 3i over 1 minus 2i, I believe is what we had, yes? And you all got the same answer as we worked it out? We hit enter. Okay, I'll need to look back and see. I think I dropped a sign somewhere. I'm going to look. Oh, yeah, 4 minus 6 is negative 2, not positive 2. So it gave you an error, didn't it? Yeah, the 84 plus doesn't like doing these in this form. But let's change it just a little bit. Because what is a fraction really saying? It's saying we're taking the numerator and dividing it by the denominator, yes? So we plug it in as 4 plus 3i divided by 1 minus 2i. Let's try doing it this way here. So we plugged it in and it gave you all decimal answers, yes? How can we turn it from a decimal to a fraction? Okay, let me see. Because math, if we hit the button math, our first option is a fraction. So we can go enter, and we get there. Now, these calculators let us do it. We just have to do a few other steps to get there. Any questions on this here? So let's look at the next one. 1 minus 4i over 2 plus 3i. So we say 1 minus 4i divided by 2 plus 3i. So again, we could type it in as division instead of in the fractional form. And hit enter. Now this time it gave us a little bit not as nice decimal answers, but that doesn't matter because if we go math, enter, enter, it gives us to us in fractional form.
How'd you get the fraction?
math.
So math.
Enter.
Oh, okay.
So negative 10/13 minus 11/13 I is the answer. And even if we have just 4i in the denominator, it works the exact same. So we could say 2 plus 5i divided by 4i. That'd be the answer. Now you will need to put parentheses around the 4i. Otherwise, it will give you a little bit different answer if we don't have them. Now, the reason for this is because the calculator saw it as 2 plus 5i over 4 times I. It saw the division, and then it multiplied it by the I. Because if we multiply it by I, we would get 2i plus 5i squared over 4. Well, that would make this negative 5 plus 2i over 4, which is negative 5/4 plus 2/4 I. Well, negative 5/4 is our 1.25, and 2/4 is our other one. Any other questions on these here? That's it.